Welcome to Linear Functions video 5. This will be a rather quick video talking just about the special cases of vertical and horizontal lines. So in this video you will explore functions that make vertical and horizontal lines, and you will look at turning vertical and horizontal lines into functions. So let's start with a vertical line function. So I'm going to do a function that just goes straight up this line, and you can see it there in pink. Now, this is a really interesting sort of situation, but if we're going to try and turn this function into something like y equals mx plus c, first we're really going to have to consider, well, what are the y-intercepts and what are the gradients? Now, unfortunately, this function is parallel to the y-axis. So, c equals what? Well, the y-intercept just doesn't exist, so c is nothing. And worse yet, it's not even 0. That's the problem we're dealing with. So we have a function where we can't even just get rid of c because it's not 0. So that makes things a little bit trickier. Well, let's have a look at m. M is what? Well, if we have a line that is not vertical, but really, really close to vertical, let's say this line, well, this line might have a triangle. You might be able to form a triangle in this line. To look at the rise over run, that might be 1, and this might be 100. So m would equal 100. That's a very steep line, but it's still not vertical. And a vertical line just wouldn't have a 1 here. It would just never make a triangle. So we have another issue there. Basically, we don't have a gradient, and we don't have a y-intercept. And the same thing happens with the horizontal lines. We have some issues there as well. So instead, what I'm going to do is I'm going to implore you to think about the coordinates we get. So let's draw some of these coordinates. First of all, this is 2, -2. And this one is 2, 1. And this one is 2, 3. And this one up here is 2, 6. And this one here is 2, 0. What I want you to see is that each coordinate is 2, some y value. And this actually means that a vertical graph has x equals 2. That vertical straight line defines every point where x equals 2, and there is no y value. So therefore there is no y-intercept, and because it's just x equals 2, there is no need for a gradient. So this fits all of our issues and sorts them all out. A vertical line is in the form x equals a, and for the same reason, a horizontal line is in the form y equals b, where a and b are just some numbers. So for example, if I just quickly plot a horizontal line here, you'll notice that for each point on this horizontal line, which I'll do in orange, we get this, -2, 3, 0, 3, 2, 3, 5, 3, 9, 3. In each case, y is equal to 3. So a horizontal line is in the form y equals some number. And that number is where it crosses the y-axis. And this a is where the vertical lines cross the x-axis. So they're the vertical lines and horizontal lines, and they're the ideas behind. So here's some examples. I've got 4 functions here, and I want to identify what they are. So let's go through them. First of all, the horizontal lines. I have an orange function here, and you can see that that crosses the y-axis at 2. So this is the function y equals 2. Remember, the horizontal lines are y equals lines. I have a purple line down here, and this crosses the y-axis at -1. So this is the function y equals -1. And then going vertically, I have a black line here, and that crosses at 3. So this is the function x equals 3. And I have a red line here, and that crosses at -1. So this is the function x equals -1. So you can see how easy that is, and how easy it is to identify lines. Notice also that the y-axis is the line x equals 0. And that's why if you want to find the y-intercept, we substitute in x equals 0. And the x-axis is the line y equals 0. And so if you want to find the x-intercept, we substitute in y equals 0. Thank you.